Okay. In our last class, we have discussed about functions, definition of functions, and domain range graphs of functions, uh, and then vertical line test for functions, also increasing and decreasing functions. How can we determine whether a function is increasing or a decreasing in a certain interval? Okay, and there are some vertical line test. Okay, now we will continue after that. Okay, we'll start today. We will start with piecewise defined functions. Do you have any idea about piecewise functions? Right. Okay, good. It can be more than two also. Okay. Okay. Uh, at first, if we go for this piecewise function, then first example will be in our mind that modulus x. Okay, here uh, modulus x is x when x is greater or equal 0, and it the value of modulus x is negative x when x is less than 0. We can also separate this modulus x, the definition of modulus x as that is modulus x equals to x when x is greater than 0, and 0 when x equals to 0, and then negative x when x is less than 0. Okay, that is the perfect example of piecewise function. And here is the graph. That means for x, that means f of x equals to x. That means here for this function, domain x is greater or equal 0. So for x is greater or equal 0, here we have this one. That means y equals to x, right? Okay, this one. And for next one, that is f of x equals to negative x. That means y equals to negative x. Okay, for this is the graph of y equals to negative x. That means f of x equals to negative x. And for this, we have here domain x less than 0. Okay, now we can go for another example that can be just like this. The function f of x equals to negative x when x is less than 0. That is the first function. And then f of x equals to x squared, that is quadratic function, and the domain of this function is in between 0 and 1. And third one is f of x equals to 1, that is a constant function, we can say, and the domain of this function is x greater than 1. So if we try to draw a graph of this function, uh, then we will have three functions here. So how does it look like? Okay, left. Okay, that means first one is f of x equals to negative x. That is y equals to negative x. So domains are here x less than 0. That means the function first one that will be in between here, that will lies here. Okay, and then for 1 x equals to 1, then we will have negative 1 y, and then x equals to 2, negative 2. Okay, is it okay? No, look at the domain. X can be positive, right? X must be less than 0. So values of x will be negative here, and then values of y will be positive, will become positive, right? So it will be negative, it will be positive. So then negative 3, and it will be 3. Okay. So 1, 2, 3. That means x negative 1. So y1 will have this one, then this point, this point. That means we will have a line, straight line, just like this. Okay. Then go for next function, that is f of x equals to x square. Here U shape, but look at the domain, 0 and 1 and 1. Okay. So that means if for this one, then it will be curve, just like, okay. And then third one, mm, y equals to 1. That means we will have a straight line, y equals to 1. And the values are domain is x greater than 1. So it will be a straight line, just like this. Okay. Good. So basically, piecewise function is used for defining several functions under a function, right? Anyone, we can start with anyone. And here is the actual function. Okay. Now, uh, if we go for even and odd functions, okay, do you know about this? Okay. That means here even and odd totally depends on the output. That means domain. If we put here f of negative x equals to, if we get f of x, then the function is even. Okay. Okay, and if we get for negative x, if we get negative f of x, then we can say the function is odd function. Okay, that means it totally depends on the output. If we get a negative sign in front of f of x for the input negative x in the given function y equals to f of x, then we can say the function is odd function. And if we get f of x only for negative x, then we can say the given function y equals to f of x is an odd function. Sorry, even function, even function. Yeah. Okay. 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 What are you asking for? Yeah. 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 Sure. Sure. Here we can consider f of x equals to x square. So what type of function it will be? That means even. Okay, let's check. If we put f of negative x equals to negative x square, then we have f of x, right? F of x. So you can say this function is an even function. Okay, but if we go for f of x equals to, you can say x, then if we put f of negative x equals to negative x, that is negative f of x, that's an odd function. Here, here is the example, that is y equals to x square. This one is an even function. And here, okay, we can go for x cube also. Y equals to x cube. That means f f of x equals to x cube. That will be an odd function. Okay, now here we are given some functions here. So if we check it, we already checked these two. This one even, this one odd. Okay, now what about f of x equals to x squared plus 1? What type of function is it? Even. And what type of function is this? Odd. Okay, now check it. F of negative x equals to negative x positive 1, that is plus 1. Okay, then No, only the value of x will change. Plus, plus 1 is a constant term. Okay. Then from here, can we rewrite this as f of negative f of x? If we take common negative sign, then we have only x minus 1, right? But the function is x plus 1. So we can't write this. So yeah. So this one is not odd. But what about even? F of negative x equals to, so yeah, this one even not even function also, even not odd. Okay. So now I think you can easily find out whether a function is an even or an odd function. Okay. Okay. We can also check this by using trigonometric function. That is, if you are given f of x equals to sine x, then what will happen if we take f of negative x equals to sine negative x? So here, what will be the next one? Can we put negative sign in front of sine x, right? Do you have any idea about this? Okay, here f of x. So this one is going to be an odd function. But what about cosine function? If you are given f of x equals to cosine, that is cos x. So now if we put f of negative x equals to cos negative x, then from here we have cos x, that means f of x. So this one is going to be an even, and this one is odd. Okay, now we can move to next one. Here are some graphs. Y equals to x squared plus 1, and then y equals to x squared. That is the shifting. I'll discuss about this later. Now we'll discuss about some common functions, that is linear function. I think you already know that. Okay, that is a linear function is in the form f of x equals to mx plus b, where m and b is called uh, m and b are constant, and this type of function is called linear function. And power function. Oh, here, mm, here f of x equals to x to the power a, where a is a constant. It's called power function. And uh, under power function, quadratic function is also a power function. No, quadratic function. We can basically separate quadratic, cubic in other categories. But if we are given f of x equals to x to the power a, so that means value of a can be even fraction or even in integer. So if a is, here is the power function. So if we have a equals to 1, then we have here f of x equals to x. That means y equals to x. So this is the graph of first one. And here, if we take a equals to 2, then we have here f of x equals to x squared. Then we will have quadratic, right? Okay, that is y equals to f of y equals to x squared. We already know about this graph. And then if we put a equals to 3, then we will have f of x equals to x cube. That means y equals to x cube. So graph of y equals to x cube is just like this. We can easily plot this using Desmos. Okay, then power 4, y equals to x to the power 4, and then x to the power 5. Okay, now y equals to 1 by x. That means f of x equals to, if the value a is -1, then we have x to the power -1, that means 1 by x. So we have here y equals to 1 by x. That is the graph of y equals to 1 by x. That means here denominator is x, so x can't be 0. Okay, right. The value of a can be integer, can be an integer, can be a fraction, can be negative integer. Okay. Uh, well, see here some other functions, that is, okay, here y equals to 1 by x. That means x can't be 0. So domain set of all domain for this function is set of all real numbers. Set of all real numbers except 0. Okay. Undefined, right? Right. Exactly. Here, if we put a equals to -2, then we have here y equals to 1 by x squared. That is the, and if we put here a equals to half, then we have f of x equals to x to the power half. That means root over x. So y equals to root over x. This one is also cover power function. Okay, this one is also under cover function. Sorry, power function. Okay, you can we can check this one also. That is x y value of a is 1 by 3. So y equals to x to the power 1 by 3. That means cubic root of x. Sorry, 1 by 3. Okay, and here 3 by 2. Okay, now go for polynomials. Uh, do you know about polynomials? What about the powers? It uh, can be negative. Okay, but power of the variable can be negative in a polynomial. Yeah, right. But it will not be a polynomial function. That means p of x or f of, we can define also f of x as uh, e x cube plus 2x to the power half plus 2 p of x here, mm, x to the power negative 3 plus 2x square plus 2 p of x equals to x cube plus 2x square plus 2. So I have written here three functions, three different uh, expressions here. Can you identify which one is a polynomial? Okay, you're talking about first one, third one, second one is not. Why second one is not a polynomial? Okay, for this portion it can't be polynomial. Okay, this one is right. But what about first one? Here we have power half. That is a fraction. Square root, right? So it can be a polynomial also. It is not a polynomial. Okay. So condition for becoming a polynomial, here we are given n. N must be an, okay, set of all natural numbers. That means n must be an positive integer. Okay. Here is okay. Here is a graph of a polynomial. Okay, look at this here. Y equals to x cube, x square, x, and constant term. The coefficients can be a fraction, but power of the variable can be a fraction or negative. Okay, natural number, right? If we go for x to the power 4, that is 8 x to the power 4 negative x cube 14 x cube negative 9 x squared plus 11x negative 1. It is also a polynomial function. Okay. Positive in natural numbers. All natural numbers are positive basically, right? Okay. Okay. Um, here, here is another one. This one is also a polynomial. If we simplify this, then we will have the power of variables is natural number. Now, rational functions. You already know this. In our previous session, we have discussed about it. That is rational number. If we have a function f of x equals to p of x by q of x, p of x and q of x, that means both are polynomial. If we have both are polynomial, that means the rational function is the quotient or ratio of two polynomials. Okay. And in this type of functions, we will uh, have a component that is called asymptotes. Asymptotes. What is asymptotes? That's the function. Here we'll discuss about function. So we can define asymptotes as also the line which it looks like the line touches the function, but it will never. Okay. Here, algebraic functions. That means here in this type of functions, we have to perform some algebraic operations. That means this type of function is involving with some algebraic operations. It can be addition, it can be subtraction, it can be multiplication, even division, or taking roots. So here rational functions. It is also an algebraic function. Okay. If it involves with algebraic operations, okay, but no. If it includes one at least, okay, algebraic algebraic function. But what about this one? If we are given f of x equals to x, can you consider this one as algebraic function? No. Okay. Good. And here trigonometric functions. If the function involving with trigonometric terms, okay, here f of x equals to sine x, f of x equals to cos. It can be tangent, it can be cotangent, it can be secant or even cosecant. Okay. exponential function, you already know that. Okay, logarithmic. Okay, now here some exercises. We have to identify whether these given functions are even or odd. Okay, this will be your task. Okay, I will, uh, in the class. Okay, I will give you a code of Google Classroom. Okay, then you will join there and you will upload there your homeworks or assignments or something else. Here, composite function. This one is very important for calculus. Basically, if we combine or if we add uh, two or three or even it can be four functions at a time, then we called this one as a composite function. Uh, do you have any idea? Yeah. Or okay. Uh, all right. Okay. Look at this one here. If we input x on g, then we have the output g of x. Okay. Again, if we use this g of x as input of other one, input of f, then we have f of g of x. So this one is called a composite function. So if we are given g of f of x, then what does it mean? That means f of x is uh, g. G is composed with f of x. Okay. So look at the notations. F of g of x. It can be written as f of g of x, or even it can be if g of x. Right. G, then g of x. G outside, then g of x inside. Okay. Now, if we look at some examples here, f of x is given as root of x, and g of x is given as x plus 1. Okay. Now, do you have copy in front of you? Okay. Okay, then calculate first one. Okay. Square root x plus 1. Okay, let us check. Here we can rewrite this f of g of x. That means f of gx plus 1, so root over x plus 1, right? Okay. Um, Now go for number C. Okay, that we can rewrite this as f of x. So f of root over s x. Then here, so root over x, right? So we can also rewrite this in terms of power, 1 over 4, right? Okay, so I think now we can complete others. Okay, now shifting graph of a function, that is also called a transformation. There are two types of shifting. That is, first one is vertical, second one is horizontal. Okay. If we add a constant with the output of a function, then the function will vertically shift it. And if we add a constant with the input, I think it sounds very weird, right? Uh, Here, look at this one. If we just add a constant with the output of a function, then shape vertically, right? For example, uh, y equals to x square. We already know the graph of this function, that is just like this, right? Okay. Now, if we add plus 1 with this, then what will happen here? It will vertically, okay, go up 1 unit, right? So it can be just like this. That is vertical shift. But if we are given here y equals to x squared, here is the perfect example of vertical shifting. Y equals to x squared. This one is the original function. If we put x squared plus 1, then this one shifted vertically upward up to 1 unit. And if we add plus 2, then it will be shifted up to 2 unit. If we put negative 2 here, then it will be shifted down up to negative 2 unit. Okay, vertically. And okay, and what about horizontal shifting? That means if we are given y equals to x squared, that is the original function. So this one will be this, just like. But if we have y equals to x minus 2 whole square, so what will happen here? Left or right? Okay, no. We are given here x minus 2. So it will move up to right, move into right 2 units. So if it is 2 here, this will be the vertex point. If we are given y equals to x plus 2 whole square, so what will happen here? Move to the left. Okay, then this one will be the vertex point. And then now uh, y equals to x plus 2 whole square negative 2. Then what will happen here? Move to the left. That means if this one is negative 2, so this one will be the vertex point. So the graph will be just like this. Regardless of the order, but you have to finally came to here, this point. Okay, if you just at first considered the vertical shifting, then you have to move downward up to 2 units. Then you have to consider horizontal, and this one you will be here. Okay. Again, if you first consider the horizontal shifting, then from here you will be there, and then if you consider vertical shifting, then you'll be here. So you can consider any of the order. Even we can check this on Desmos, then we'll find easily uh, forms, right? Here now scaling and reflecting factors. That means how the functions compress or stretches that depends on the uh, factor. Here, if we go for an example, then it will be easier. Uh, f of x equals to, again we can check for quadratic, or even we can, okay, now if we go for sine function, that is sine wave. Okay, sine function. What is the graph of this sine function? Wave, and it starts from origin point. Okay, just like this. So here, this one is called the amplitude. Okay, then this length is called the period of the function. We can consider to first local maximum point. These are the maximum point. This one is also the length of the period. Mm, we can consider the distance between two local maximum point, or even it can be distance between two local minimum points also. From this one to this one, the lengths are same. Okay. Now, here the period is basically for the f of x equal for sine x, that is 2 pi. That means if the function, if a particle start moving from a point, and it if it moves up to this, and to this point, that means in this point, if we cut this graph from here, and if we paste this one here, then it will form a complete graph. Okay, so now if we have here f of x equals to sine 2x, then how does the function graph looks like? It will compress or stress. Which one? Compresses. It will compress, right? So then we will have just like this type of function. It will compresses here, so just like this, shorter, right? The period will be shorter. That means it will take less time to complete a, uh, even if we go for Desmos, it will be clear, I think. It will be easier for us. Okay. Can you see the screen? Okay. If we have f of x equals to sine x, that is the sine curve. Okay. But if we put f of x equals to sine 2x, then we see here it takes lesser time, right, to uh, complete one oscillation. Okay. So I will discuss about this later. This one is very important for us to uh, determine whether a function uh, takes how many or how much time to complete its oscillation, if it is for sine function or cos function, or even we can go for algebraic function, even we can go for power function. uh, okay, we can determine easily using this factor whether the function compresses or it will stresses. Okay, here are the some examples I will discuss about this. Okay, this will be your home task also. Okay, this will be your task. These are composite function basically. Okay, okay. I'll post it on Google Classroom. You can join there. Okay, I will give you the code. Okay, okay. Thank you. That's all for today. Okay, 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 okay. Have a good day. Thank you.